In this video, we are looking at the Unit 5 review. This is on page 32 of your math workbook. And you can use a calculator on this one, which is a good thing. Number 1. Leroy separates his baseball cards into 4 piles with the same number of cards in each pile. How many total cards could Leroy have? So I know that whatever number of cards Leroy has, it must be divisible by 4. So this is testing the divisibility rules. And the divisibility rule for 4 says that the last 2 digits of your number has to divide by 4 with no remainder. So that would have to be this one. 24 can be divided by 4. So number 1 is D. Number 2. Monica makes a list of prime numbers. Which 3 numbers could be on the list? So in this one, you are looking for prime numbers, which means the only factors they have are 1 and themselves. A is one of them. 3 is prime. 19 is prime. And 23 is prime. Now, because this is a review, let's review why the others cannot be prime. The 9, if you list the factors of 9, 9 is a composite. You have 1 times 3. 1 times 9. You also have 3 times 3. So 9 is composite. 16 is composite. You do have 1 and 16, but you also have 2 and 8, and you have 4 and 4. And then 27 is not prime because it has 1 and 27. It also has 3 and 9. We need prime numbers in this one. So number 2 is A, D, and E. Number 3. 2 of the factors of a number are 3 and 5. Which number could it be? So we know that our answer must be divisible by 3 and 5. Now, B I can eliminate because it is not divisible by 5. For 5, you have to end in 5 or 0. So B is not divisible by 5. But these other 3 do have 5s and 0s on the end. So let's test them for 3. And remember, for divisibility by 3, you do the sum of the digits. So you have 1 plus 1 plus 5 is 7. 7 divided by 3, that won't work. 1 plus 3 plus 0 is 4. 4 divided by 3, that won't work. 1 plus 6 plus 5 is 12. And 12 divided by 3 absolutely will work. So D is divisible by both the 3 and the 5. Number 3 is D. Number 4. Amelia writes a number that is a multiple of 9. Which number could it be? Now, you can list the multiples of 9 if you want to do that. But here's another way. If it's a multiple of 9, it's divisible by 9. And remember, the divisibility rule for 9 is you do the sum of the digits. So 1 plus 0 plus 8, that is 9. That is one of them. 1 plus 2 plus 3, that's 6. You can't do 6 divided by 9 to get an even number. 1 plus 1 plus 8, that's 10. That's not divisible by 9. 1 plus 3 plus 6, that's 10 again. So the one that is divisible by 9 would be A. 108 is a multiple of 9. You could also just list the multiples. You would have to go to the 12th one to get that, but you can certainly do it that way. Number 4 is D. Number 4 is A. Number 5 is D. I didn't mean to do that, but I already saw it, so we know it's D, but let's see why it's D. The soccer coach separates 72 cones and 48 ropes into identical stations. What is the greatest number of stations the coach can make? So remember, when we see these keywords, we need to focus on the greatest something. The greatest common factor. Now, just because we learned it this way, bear with me, there it is. Remember, I taught you how to do those using this F. So this is a review lesson that we're working on. So let me bring one of these in just to remind you. I want you to use those memory pieces. You made them for a reason. So use them to help you with this. So greatest common factor. And of course, this is not the problem I'm trying to work. Let me get those out of there. The greatest common factor of 72 and 48. So 72, let's list the factors. I have 1 times 72, 2 times 34. Is that right? Bear with me. 36, excuse me. 3 will work because it's divisible by 3. 3 times 24. 4 times 18. 5 won't work. 6 will. 6 times 12. And then 8 times 9. So there are the factors of 72. Here are the factors of 48. 1 and 48. 2 and 24. 3 and 16. 4 and 12. 6 and 8. Then I'm looking for the greatest one that they have in common. So we have, of course, the 1. That's not going to help me, though, but we can mark it. They both have a 2 and a 3. They both have a 4 and a 12. They both have a 6 and an 8. They both have a 24. And I think that's the biggest one. So the greatest common factor they have is 24. And that will give you your answer. The coach can make 24 of these stations. Number 6. Brandon has 24 nickels, 36 dimes, and 42 quarters. What is the greatest number of identical groups he can separate the coins into with no coins left over? See the similarity to this one? It's the same set of keywords, greatest number of identical groups. So we are going to need the letter F again. We're going to break this down into common factors. So let me just put it right there. I will have to clean this one out. Now this time we have 3 groups, but that's okay. You can still do that. I think we've done some of them as examples. So, and I'll tell you what, if you will bear with me for just a second, I'm going to get rid of this line so that's not in the middle of your view. So I'm just taking out, erasing out that part. The F happened to land on that line and I don't want it there. Okay, so the numbers that we're dealing with, we have 24. That's the smallest one, so let me put it down here. I'll just put it right there. And then the 42 and the 36. So I need to list factors for 3 of these. The 42 is going to be 1 times 42, 2 times 21, 3 will work, times 1, 4. 4 won't work, 5 won't work, 6 will, 6 and 7. Then for 36, I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And then 24, I have a 1 and a 24, a 2 and a 12, a 3 and an 8, and a 4 and a 6. So I need to get common factors for all of them. The 1 is in all of them. The 2 is in all of them. The 3 is in all of them. The 6 is in all of them. And that's all, I believe. So the number you're looking for is D, 6 groups. And we found that by the greatest common factor. Okay, number 7. Carrie calls her friend every 4 days and her mom every 5 days. How often does she call her friend and her mom on the same day? Now there's the key word. We're not breaking down into factors this time. We are building up into multiples this time. We're doing a multiple mountain. So in your notebook, this is how I showed you to do those. You don't have to draw the M if you don't want to, but that's the memory piece that goes with this problem. So we have her friend on one part of the M, which is every 4 days, and her mom is every 5 days. And we want to know when she will call both of them on the same day. So let's list, remember I start with the big one, you don't have to, but 5, 10, 15, 20 is a good one, 25. Then over here I have 4, 8, 12, 16, 20, 24, but 20 is the one I'm looking for. So every 20 days, that's the least common multiple, so every 20 days she will call both of them on the same day. So number 7 is B. Number 8. Jerry makes $15 an hour and Macy makes $18 per hour. They work full-hour shifts. What is the least amount of money Jerry and Macy could earn and have the same amount? That's another least. There's the word least. And same. So we're looking for a least common multiple. And I have Jerry and Macy. Let me find my problem again so I don't have to keep scrunching that up there. Jerry is 15. Macy is 18. And we're looking for the least common point between those two. I like to start with the larger one. You don't have to, but I'm looking for the ones of 18. So I have 18 times 1, 18 times 2, 18 times 3. You can use your calculator, so I'm going to. I'm trying to, guys. I can't get, there we go. 18 times 3 is 54. 18 times 4. 18 times 5. Okay, let's try that 90. I think that one might work, but let's see. So then we have 15, 30, 45, 60, 75, 90. There we go. So $90 is the least amount they could make and have the same amount. Number 8 is D. Number 9 is to find the next 3 numbers in the pattern. So you know how I'm going to do this one. You don't have to if you don't like the table, but this is my way of doing it. And I have 4 inputs. I add a row to make a total of 5. Oh no, I'm sorry. We need to find the next 3. So they want us to do a total of 7 there. There's 4, 5, 6, and 7. So make columns. This is not a story problem, so input, output will work just fine. Input, rule, and I think I'm 1 short. That's okay. I think I can just shrink my table a little bit. Maybe, yes. And then I'll add that extra row down there. But we have a 5 and a 13, a 13 and a 29, a 29 and a 61, a 61, and then we don't know the output on that one. So we need to figure out the rule. Now the rule, I know we're building up because if you look at the input and the output, you can see that it's getting bigger. So we know that we're building up. That is clearly not going to work, guys. I'm sorry. But I do need one more. So how do I get from 5 to 13? Plus 8. But then when I try that here, doesn't work because 13 plus 8 is 21. So that is not the pattern, unfortunately. I wish it were. I'm going to go ahead and tell you the pattern because we could spend all day here looking at this. It is multiply by 2 and then add 3. 5 times 2 is 10, plus 3 is 13. 13 times 2 is 26, plus 3 is 29. 29 times 2 is 58, plus 3 is 61. 61 times 2 is 122, plus 3, and I'm going to go ahead to my calculator. I need to be sure of this. Remember, you don't want to make a mistake in one of these cells. But we were okay there. Then 125 is your new input, times 2, plus 3 is 253. Then 253 times 2 is 506, plus 3 is 509. Then 509 times 2 is 1012, plus 3 is 1015. But we can stop because we have our next 3 inputs. We have 125, 253, and 509. So that is answer A. Number 9 is A. Okay, number 10, we have another pattern. It says, what is the rule for this pattern? And I have 4 inputs. So let me see if I can make a table. It doesn't need to be very big. I need 5 rows. So we have 1, 2, 3, 4, and then there's the 5th one. I'll take off this bottom. Okay, and we're looking for the rule this time. And they give me some to choose from. These are the ones I like much better. So let's plug in what we know, and we'll see which one of these rules will fit. So make your table, get your input and outputs going, and then we'll figure out which one of those rules will actually work for what we want to do. So here's input. Here's the space for the rule, and then here's the output. So we've got 216, 144. Let's try 216 divided by 3. That's 72. So A is not the pattern that I'm looking for. Okay, B says divide by 2 and then times 3. So let's see if this one works. 216 divided by 2 is 108, times 3 is 324. That one does not work. Sorry, that's not it either. So how about divide 3 times 2? 216 divide 3 is 72, times 2 is, So let's see if it works on this next row. Let's see if we can divide by 3 and multiply by 2. So 144 divided by 3 times 2, it does work. So let's see if it works on the next one. 9664. So 96 divided by 3 is 32, times 2 is 64. It did work. So that's the pattern that I'm looking for. It's C. You just try those until you find the one that fits. So number 10 is C. Okay, number 11. Dan participates in a 2-month reading challenge. He reads 20 pages the first week, 30 pages the second week, 50 pages the third week, and 90 pages the fourth week. How many pages does Dan read during the 8th week? So let's sketch a table. We want to go to the 8th week, so I'm going to make 9 rows. This is a story problem, so I'm going to add that extra column this time. You certainly don't have to, but it helps me, and I hope it helps you. And I always manage to get it just a little too long, don't I? All right, so 4 columns. There's 1, 2, 3, 4. In the first column, I'm going to list the weeks, and then the input, the rule that we'll have to figure out, and the output. So week 1, 2, and remember I like to write words here so that I'm not creating numbers that I can accidentally get mixed in with my problem. I would much rather work with the words here. Okay, during the first week he does 20. He does 30 the second week, so that would make this be the output up here. 50 the third week. And 90 the fourth week. And then we're supposed to figure out this number, what goes in that spot. So you and I are going to have to figure out the pattern, the rule that's happening here. Now, it looks like building up, okay? Because we're going from 20 to 30, and it is building up. It's also breaking down. The rule that we're doing here that will fit this whole table is first you double it, and then you subtract 10 pages. 20 times 2 is 40, minus 10 is 30. 30 times 2 is 60, minus 10 is 50. 50 times 2 is 100, minus 10 is 90. 90 times 2 is 180, minus 10 is 170. Then 170 times 2 is 340, minus 10 is 330. 330 times 2 is 660, minus 10 is 650. 650 times 2 is 1300, minus 10 is 1290. And look at this. There is the missing piece. So for number 11, I like C. That is not an easy problem. Okay, number 12. Joanne buys a shirt with no sales tax for $13.95 and a home decoration for $12.50 plus 6% tax. Which expression represents how much money Joanne spends? So she buys the shirt, plus the home decoration. The shirt is $13.95 and there is no tax on that. Plus the decoration is $12.50 times the sales tax, which is 100% of the price at 6%. So for this one, I like B as in boy. Sales tax is multiplied by your price. Number 12 is B. And I really want to put parentheses around that, but you don't have to, because the order of operation says that you multiply before you add. Number 13. Aaron runs 2 miles 12 times this month. Let me highlight on this one. 2 miles 12 times. He runs 5 miles 3 times this month, and he runs 13 miles once. So how many miles does Aaron run this month? He does 2 miles 12 times, and 5 miles 3 times, and 13 miles 1 time. Multiply before you add. So 24 plus 15 plus 13. Now you're ready to add those 3 numbers up, and you can use your calculator. That is 52 miles. And that is C. Number 14. Miranda deposits $100 into a checking account twice this month. 3 days during the month, she buys coffee for $3. That's 3 days. She buys coffee for $3 and a bagel for $2. She pays a $67 cell phone bill from the account as well. Which expression represents how much Miranda's checking account balance changes this month? I'm going to go to my scrap paper for this one. So let's call this number 14. Let me get my page back over here. So let's write down all that she does. She has the deposit. Then she buys food. And she pays a cell phone bill. Is that everything? Yes. Okay, so let's see what we have number-wise. The deposit was $100, but she did it twice. For 3 days during the month, she bought coffee, which was $3, and a bagel, which was $2. And then she paid the cell phone bill. That was only 1 time. So here's what we have to do. Parentheses first. So we're going to add up the food. And then we're going to multiply left to right. So we have $200 here. We have $15 here. And then we're going to subtract from left to right. Or you can just type all of that into your calculator. So 200 minus 15 minus 67 is 118. And I believe that is not even the question, is it? The question is how did the balance change? How did her balance change during the month? And what we did was C. We multiplied the deposit, we subtracted the food, and then we subtracted the cell bill. So the answer to number 14 is C. Okay, number 15. When Caleb simplifies the expression, he incorrectly writes a fraction for the answer. What is the correct answer? So I'm just going to squeeze this one in right here, I think. 7 minus 2 divided by 5 plus 3 times 2 plus 1 minus 4. So I need to do parentheses first. I need to say 7 minus 2 is 5, and 2 plus 1 is 3. And then I need to copy the stuff I haven't used yet. And then I multiply or divide from left to right. So I have division and multiplication. And I copy, and then I add and subtract from left to right. So 10 minus 4, I think it's going to be 6. So for number 15, I like B. The answer is 6. They're testing whether you know the order of operations. Number 16. Jackson has 55 pens and 66 pencils. He separates them into identical groups to give away as gifts. What is the greatest number of groups Jackson can make? The greatest identical factor. So we need, let me keep following the method I've shown you. I need one of these F's. You don't have to draw this. I just want you to know where this is in your notebook. We're looking for the greatest common factor for these two numbers. Learn to look for those key words, and that'll help you know. Greatest identical is the same as greatest common. All right, so we have pencils are 55, and pencils are 66. 1 times 55, 5 times 11. 1 times 66, 2 times 33, 6 times 11, 3 times 22. But I see it. The greatest common factor that both of them have is that 11. So for number 16, I like C. 11 identical groups. Number 17. Kyle practices bass for the same amount of time 3 times a week. He also practices guitar for 30 minutes 4 times a week. He practices a total of 180 minutes a week. How much time does Kyle spend each time he practices the bass? So be careful here. Let me go back through. He practices bass for the same amount of time 3 times a week. He practices guitar for 30 minutes 4 times a week, and a total of 180 minutes per week. So let's write that. We have the bass plus the guitar. That's what total means. Plus is 180 minutes. We know that he practices 3 times a week on the bass, but we don't know how long. We know that he practices the guitar for 30 minutes 4 times a week. And again, that's going to equal 180. So I have 36b plus 120, you do this multiplication, is 180. So I have an algebra equation here that we need to solve. So I'm going to minus 120 and minus 120. So I'm left with 3b. I don't know where I got 36. Oh, I do. I thought that b was a 6. 3b equals 60. And then divide both sides by 3. So each time he practices base, he does it for 20 minutes. Number 17 is A. It's a good algebra equation. Number 18. Kathy sells 3 magazines 5 times on Monday. She buys 16 magazines on Tuesday. How many total magazines does Kathy gain or lose this week? So I want you to imagine that you are at Kathy's house. And in her house, there are magazines sitting everywhere. My dad did this once. He bought all these hundreds of National Geographics. They were sitting everywhere in our house. So that's like Kathy's house. There are magazines everywhere. If she sells magazines, that means that they are leaving her house or her possession. So we have 3 magazines 5 times. This is on Monday. So I would say that 15 magazines leave her house on Monday. That is leaving her house. On Tuesday, though, she buys 16 magazines. That means that 16 magazines are coming in to the house. So if she got rid of 15, but then she turned right around and brought in 15 and 1 more, that means that she has gained a magazine. And that is answer B. That question is a little bit tricky to me. The way it's worded, I think, is a little bit hard, at least for me. It may not be for you, but it helps to think of a story that goes with it. So 18, the answer is B. Number 19. Jared climbs twice as high up a mountain on the second day as he climbed on the first day. On the third day, Jared begins his climb down the mountain and descends 300 feet. At the end of the third day, he is 1,200 feet up the mountain. How high did Jared climb on the first day? Okay, this one is a brain bender. And I encourage you to draw yourself a mountain. Okay, just sketch yourself a picture. It doesn't have to be perfect. So here's the mountain. Here's the base of the mountain. And we know that Jared went up the mountain on the first day. We'll call that F. And on the second day, he went 2 times that. So this is the first day. And then the second day, he went double what he did on the first day. So those two variable terms there are 2 days, the first 2 days. Then on the third day, what happened? Did he keep going up, or did he start coming back down? He started descending. Okay, so he went up the mountain on the first 2 days to this point, and then he turned and started to come back down the mountain. Now that's where this one's a little bit tricky, because you've got directions going on. We know that the first 2 days he was climbing, and then the third day he was coming back down the mountain. Okay, and we know that he actually descended 300 feet. So get fixed in your mind what's happening in this problem. And here it is in math terms. Let me see, I may have to shrink this to get it to fit in here. Let's try again here. Just going to resize. I'm still getting used to this new iPad, and it's just a hair different. So here's what you could say if you want to set it up in word form. We're going to take the first day plus the second day minus the third day, because on the third day he started back down. He turned around. And then when we leave him on the mountain, he is at 1,200 feet. So the first day was F. The second day was double that. And then he came back down 300 feet, and now he's at 1,200. So that's what this looks like in word form. Now we're going to solve this bad boy right here, but I need to make him a little bit smaller so I can fit it all in here. Okay, so let me zoom in. Here is, go ahead and put your power T in. That'll help you keep it straight. So we're going to combine like terms. We have F plus 2F right here. That's 3F minus 300 is 1,200. So move the 300. And we have 3F equals 1,500. Divide by 3. So on the first day, he went 500 feet. The first day was 500. The second day was 500 times 2, so that's 1,000. Then he came down 300, and we're leaving him on the mountain at 1,200 feet. But the question is, how high did Jared climb on the first day? And that is C, 500 feet. What a problem that is. I like that one, but it's a brain bender. Okay, last one. LaToya goes to the bank every 7 days, and Harry goes to the bank every 9 days. How often do LaToya and Harry go to the bank on the same day? What's the first time they'll meet on the same day? And hopefully you remember that that is one of these kinds of questions. When it says same, you're looking for common multiple. So let's put LaToya on one side. And Harry on the other side. LaToya goes every 7 days and Harry goes every 9 days. And we want to know the least amount of time it will take for them to meet. 9, 18, 27, 36, 45, 54, 63. Thought I skipped one, but I didn't. And then we have 7, 14, 21, 28, 36, not 36, 35, 42, 49, 56, 63. So every 63 days, they will be at the bank on the same time. I want to show you a little trick with the 9s. Actually, just one second. Number 20 is C. When you have to list your multiples of 9, if you don't know your 9 times tables, here's how it works. This is really cool. List your numbers, just like I'm doing. Okay. And then turn around and do it the other way. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are your first 10 multiples of 9. So if you have trouble remembering your times tables, this will work for the 9s. I don't know another trick for another number, but it will work for the 9s. Count down the line, and then turn around and reverse it up the line, and you will have your first 10 multiples of 9. Okay, that brings us to the end of this chapter. So I will see you in the next video. We will start learning about measurement, and I hope you will enjoy that lesson. Remember, if you have questions, do not hesitate to contact your instructor. He or she will be happy to help you. I will see you soon, and I hope you have a really good day. Bye-bye.